As a security analyst, you'll work with a lot of data. Being able to develop solutions for managing this data is very important. What we're about to learn in Python will help you with that. Here, we'll build on that in a few different ways. First, you'll learn more about working with strings and lists. We'll expand the ways that you can work with these data types, including extracting characters from strings or items from lists. Our next focus is on writing algorithms. You'll consider a set of rules that can be applied in Python to solve a security-related problem. And finally, we'll further expand the ways we can search for strings when we explore using regular expressions. We're going to have a lot of fun, and you'll start writing some really interesting code in Python. I can't wait to get started. Knowing how to work with string data in security is important. For example, you might find yourself working with usernames to find patterns in login information. We're going to revisit the string data type and learn how to work with it in Python. First, let's have a quick refresher on strings. We defined string data as data consisting of an ordered sequence of characters. In Python, strings are written in between quotation marks. It's okay to use either double or single quotation marks, but in this course, we've been using double quotation marks. As examples, we have the strings hello, 1, 2, 3, and number 1. We also previously covered variables. Here, the variable myString is currently storing the string security. You can also create a string from another data type, such as an integer or a float. To do that, we need to introduce a new built-in function, the string function. The string function is a function that converts the input object into a string. Converting objects to strings allows us to perform tasks that are only possible for strings. For example, we might convert an integer into a string to remove elements from it, or to reorder it. Both are difficult for an integer data type. Let's practice converting an integer to a string. We'll apply the string function to the integer 123. Now, the variable newString contains a string of 3 characters, 1, 2, and 3. Let's print its type to check. We'll run it. Perfect. It tells us that we now have a string. Awesome. So far, we know different ways to create and store a string. Now, let's explore how to perform some basic string operations. Our first example is the length function. The length function is a function that returns the number of elements in an object. Using it on a string tells us how many characters the string has. Earlier in the program, we learned that IP addresses have 2 versions, IPv4 or IPv6. IPv4 addresses have a maximum of 15 characters. So, a security professional might use the length function to check if an IPv4 address is valid. If its length is greater than 15 characters, then we'd know that it's an invalid IPv4 address. Let's use this function to print the length of the string hello. We'll nest the length function within the print function because we want to first calculate the length of this string and then print it to the screen. Okay, let's run this and check out how many characters Python counts. The output is 5, 1 for each letter in the word hello. We can also use the addition operator on strings. This is called string concatenation. A string concatenation is the process of joining 2 strings together. For example, we can add the strings hello and word together. To concatenate strings, we can use the plus symbol. After we run it, we get hello word, with no spaces in between the 2 strings. It's important to note that some operators don't work for strings. For example, you cannot use a minus sign to subtract the two strings. Finally, we're going to talk about string methods. A method is a function that belongs to a specific data type. So, using string methods on another data type, like an integer, would cause an error. Unlike other functions, methods appear after the string. Two common string methods are the upper and the lower methods. The upper method returns a copy of the string in all uppercase letters. Let's apply the upper method to the string hello. We'll place this inside of a print function to output it to the screen. Let's focus on the unique syntax of methods. After our string hello, we place a period or dot, and then specify the method we want to use. Here, that's upper. Okay, now we're ready to run this. Hello is printed to the screen in all uppercase letters. Similarly, the lower method returns a copy of the string in all lowercase letters. Let's apply the lower method on the hello string. Remember that we need to put the string and the method inside of a print function to output the results. And now we have the string printed in all lowercase letters. Coming up, we're going to learn a lot more about strings, like indexing and splitting strings. I'm looking forward to meeting you there. In security, there are a variety of reasons we might need to search through a string. For example, we might need to locate a username in a security log. Or if we learn that a certain IP address is associated with malware, we might search for this address in a network log. And the first step in being able to use Python in these ways is learning about the index of characters in a string. The index is a number assigned to every element in a sequence that indicates its position. In this video, we are discussing strings. So, the index is the position of each character in a string. Let's start with the string hello. Every character in the string is assigned an index. In Python, we start counting indices from 0. So the character H has an index of 0, and E has an index of 1, and so on. Let's take this into Python and practice using indices. Placing an index in square brackets after a string returns the character at that index. Let's place the index 1 in square brackets after hello and run it. This returns the character E. Remember, indices start at 0, so an index of 1 isn't the first character in the word. But what if we wanted to return more than just one character? We can extract a larger part of a string by specifying a set of indices, and this is called a slice. When taking a slice from a string, we specify where the slice starts and where the slice ends, so we provide two indices. The first index is the beginning, which is included in the output. The second index is the end, but it's not included in the final output. Instead, Python stops the slice at the element before the second index. For example, if we wanted to take the letters E, L, L from hello, we would start the interval from the index 1, but we'd end before the index 4. Let's try this example and extract a slice from a string in Python. Let's type in the string and take the slice starting at index 1 and ending before index 4. Now, let's run the code and examine the output. And there's the slice we wanted. Now that we know how to describe the location of a character in a string, let's learn how to search in a string. To do this, we need to use the index method. The index method finds the first occurrence of the input in a string and returns its location. Let's practice using the index method in Python. Let's say we want to use the index method to find the character E in the string hello. We'll locate the first instance of the character E. Let's examine this line in more detail. After writing the string and the index method, we use the character we want to find as the argument of the index method. Remember, strings in Python are case sensitive, so we need to make sure we use the appropriate case with the index method. Let's run this code now. This returns the number 1. This is because E has an index value of 1. Now, let's explore an example where a character repeats multiple times in the string. Let's try searching for the character L. We start with similar code as before, passing the argument L instead of E to the index method. Now, let's run this code and investigate the result. The result is the index 2. This tells us that the method only identified the first occurrence of the character L and not the second. This is an important detail to notice when working with the index method. As a security analyst, learning how to work with indices allows you to find certain parts in a string. For example, if you need to find the location of the @ symbol in an email, you can use the index method to find what you're looking for with one line of code. Now, let's turn our attention to an important property of strings. Have you ever heard the expression, "some things never change"? It might be said about the comfortable feeling you have with a good friend, even when you haven't seen them for a long time. Well, in Python, we can also say this about strings. Strings are immutable. In Python, immutable means that it cannot be changed after it's created and assigned a value. Let's break this down with an example. Let's assign the string hello to the variable myString. Now, if we want to change the character E to an A, so myString has the value HALLO, then we might be inclined to use index notation. But here, we get an error. MyString is immutable, so we cannot make changes like this. And there you have it. You just learned how to index and slice into strings. You've also seen that strings are immutable, so you cannot reassign characters after a string has been defined. Coming up, we'll learn about list operations and see that lists can be changed with index notation. Another data type we discussed previously is the list. Lists are useful because they allow you to store multiple pieces of data in a single variable. In the security profession, you will work with a variety of lists. For example, you may have a list of IP addresses that have accessed a network, and another list might hold information on applications that are blocked from running on the system. Let's recap how to create a list in Python. In this case, the items in our list are the letters A through E. We separate them by commas and surround them with square brackets. We can also assign our list to a variable to make it easier to use later. Here, we've named our variable myList. When we access specific elements from lists, we use syntax similar to when we access specific elements from strings. We place its index value in brackets after the variable that stores the list. So this would access the second item in the list. This is because in Python, we start counting the elements in a list at 0 and not at 1. So the index for the first element is 0, and the index for the second element is 1. Let's try extracting some elements from a list. We'll extract the second element by putting 1 in brackets after the variable. We place this in a print function to output the results. And after we run it, Python outputs the letter B. Similar to strings, we can also concatenate lists with the plus sign. list concatenation is combining two lists into one by placing the elements of the second list directly after the elements of the first list. Let's work with this in Python. Let's concatenate two lists. First, we define the same list as in the previous example and store it in the variable myList. Now, let's define an additional list with the numbers 1 through 4. Finally, let's concatenate the two lists with a plus sign and print out the result. And when we run it, we have a final concatenated list. Having discussed the similarities, let's now explore the differences between lists and strings. We mentioned earlier that strings are immutable, meaning after they are defined, they cannot be changed. Lists, on the other hand, do not have this property, and we can freely change, add, and remove list values. So, for example, if we have a list of malicious IP addresses, then every time a new malicious IP address is identified, we can easily add it to the list. Let's first try changing a specific element in a list in Python. We start with the list used in the previous example. To change an element in a list, we combine what we learned about bracket notation with what we learned about variable assignment. Let's change the second element in my list, which is the string b, to the number 7. We place the object we want to change on the left-hand side of the variable assignment. In this case, we'll change the second element in my list. Then, we place an equal sign to indicate we are reassigning this element of the list. Finally, we place the object to take its place on the right-hand side. Here, we'll reassign the second list element to a value of 7. Now, let's print out the list and run the code to examine the change. Perfect! The letter B is now changed to the number 7. Now, let's take a look at methods for inserting and removing elements in lists. The first method we'll work with in this video is the insert method. The insert method adds an element in a specific position inside a list. The method takes two arguments. The first is the position we're adding the element to, and the second is the element we want to add. Let's use the insert method. We'll start with the list we defined in our myList variable. Then we type mylist.insert and pass in two arguments. The first argument is the position where we want to insert the new information. In this case, we want to insert into index 1. The second argument is the information we want to add to the list. In this case, the integer 7. Now, let's print my list. Our list still begins with A, the element with an index of 0. And now we have the integer 7 in the next position. The position represented with an index of 1. Notice that the letter B, which was originally at index 1, did not get replaced like when we use bracket notation. With the insert method, every element beyond index 1 is simply shifted down by one position. The index of B is now 2. Sometimes, we might want to remove an element that is no longer needed from a list. To do this, we can use the remove method. The remove method removes the first occurrence of a specific element in a list. Unlike insert, the argument of remove is not an index value. Instead, you directly type the element you want to remove. The remove method removes the first instance of it in the list. Let's use the remove method to delete the letter D from our list. We'll type the name of our variable, myList, then add the remove method. We want to remove D from this list, so we will place it in quotation marks as our argument. Then we'll print myList. And let's run this. Perfect. D has now been removed from the list. Just like with strings, being able to search through lists is a necessary skill for security analysts. I'm looking forward to expanding our understanding as we move forward in this course. In our everyday lives, we frequently follow rules for solving problems. As a simple example, imagine you want a cup of coffee. If you've made coffee many times, then you likely follow a process to make it. First, you grab your favorite mug. Then, you pour water into the coffee maker and add your coffee grounds. You press the start button and wait a few minutes. Finally, you enjoy your fresh cup of coffee. Even if you have a different approach to making coffee or don't drink coffee at all, you likely follow a set of rules for completing similar everyday tasks. When you complete these routine tasks, you're following an algorithm. An algorithm is a set of rules that solve a problem. In more detail, an algorithm is a set of steps that take an input from a problem, uses this input to perform tasks, and returns a solution as an output. Let's explore how algorithms can be used to solve problems in Python. Imagine that you, as a security analyst, have a list of IP addresses. You want to extract the first 3 digits of each IP address, which will tell you information about the networks that these IP addresses belong to. To do this, we're going to write an algorithm that involves multiple Python concepts that we've covered so far: loops, lists, and strings. Here's a list with IP addresses that are stored as strings. For privacy reasons, in our example, we're not showing the full IP addresses. Our goal is to extract the first 3 numbers of each address and store them in a new list. Before we write any Python code, let's break down an approach to solving this problem with an algorithm. What if you had one IP address instead of an entire list? Well, then the problem becomes much simpler. The first step in solving the problem will be to use string slicing to extract the first 3 digits from one IP address. Now, let's consider how to apply this to an entire list. As the second step, we'll use a loop to apply that solution to every IP address on the list. Previously, you learned about string slicing, so let's write some Python code to solve the problem for one IP address. Here, we are starting with one IP address that begins with 198.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168. the first three characters. We'll use the bracket notation to slice the string. Inside the printf statement, we have the address variable, which contains the IP address we want to slice. Remember that Python starts counting at 0, so to get the first three characters, we start our slice at index 0. And then continue all the way until index 3. Remember that Python excludes the final index. In other words, Python will return the characters at index 0, 1, and 2. Now, let's run this. We get the first three digits of the address, 198. Now that we're able to solve this problem for one IP address, we can put this code into a loop and apply it to all IP addresses in the original list. Before we do this, let's introduce one more method that we'll be using in this code, the append method. The append method adds input to the end of a list. For example, let's say that my list contains 1, 2, and 3. With this code, we can use the append method to add 4 to this list. First, we're given the IP list. Now, we're ready to extract the first 3 characters from each element in this list. Let's create an empty list to store the first 3 characters of each IP from the list. Now, we can start the for loop. Let's break this down. The word for tells Python that we are about to start a for loop. We then choose address as the variable inside of the for loop, and we specify the list called IP as the iterable. As the loop runs, each element from the IP list will be stored temporarily in the address variable. Inside the for loop, we have a line of code to add the slice from address to the networks list. Breaking this down, we use the code we wrote earlier to get the first 3 characters of an IP address. We'll use our append method to add an item to the end of a list. In this case, we're adding to the networks list. Finally, let's print the networks list and run the code. The variable networks now contains a list of the first 3 digits of each IP address in the original list, IP. That was a lot of information. Designing algorithms can be challenging, so it's a good idea to break them down into smaller problems before jumping into writing your code.